Here we're given three functions. The function f is given as a table of data, the function g is given as a graph, and the function h is given by this equation. We have a multiple choice question that just says which one of the following is true. So for the first part it says f inverse of 0 is 4. But notice, even though they're asking about the inverse function, the data is given in terms of the function f. So one way to do this is to take the question and rewrite it in terms of the function f, because the data given was in terms of f, not f inverse. So we know that if f inverse of 0 is 4, that means that f of 4 is 0, right? The inputs and outputs get switched. So this statement, for it to be true, would mean that when you plug 4 into the function, you get out 0. Looking at the chart, there's not even a number 4 in the row for my input variable x. So simply put, this function is not even defined at x equals 4. So how can we say that the function has a value of 0 at 4? We cannot. So this is not a true statement. This is false. Choice B can be done in a similar way. Choice B says that f inverse of 0 is negative 4, which is equivalent to saying that if you were to plug negative 4 into the function f, you would get out 0. Once again, my function f is undefined at x equals negative 4. It's not even a choice in the list. So therefore, choice B is false. If you're curious what a true statement would be with regards to the part of the chart that has a 4 involved and a 0, the chart does say that f of 0 is 4. So it would be a true statement that f inverse of 4 is 0. This would be true, but it's not even one of my choices. So let's move on to part C. Part C says that g inverse of 0 is negative 4. So on a graph, the x-axis is your input variable x, and my output variable here will be g of x. Again, since this is using inverse, and the graph was given in terms of g, not g inverse, one way to approach the problem is just to translate this statement from g inverse to g by just saying if g inverse of 0 is negative 4, then g of negative 4 must be 0. If this is true, that would mean on the graph you would see the point negative 4 comma 0, right? This notation means if the input's negative 4, the output is 0. If you look at the graph at negative 4 is 0, there is no point at negative 4, 0. So therefore, this statement is false. If you were looking at this point right here thinking that that was important, let me show you why that doesn't work in this problem. That point right there has coordinates 0 comma negative 4. Which means g of 0 is negative 4. So if I wanted to make a true statement with regards to g inverse, a true statement would be that g inverse of negative 4 would be 0. This is true. The problem is this is not a choice in my list. At no time are we plugging negative 4 as an input into the inverse of g. So part C is wrong as well. This brings us to part D. Part D says that h inverse of 0 is 4. For that to be true, that would mean h of 4 is 0. So remember, since 0 is the input into h inverse, it would be the output of h. So this statement means if we replaced x with 4, that we'd get out 0. And if you do that, you'll see that you get negative 8 plus 4, which is most decidedly not 0. So if h of 4 isn't 0, then h inverse of 0 cannot be 4. Because I like to show how to do problems in multiple ways, another way to do this problem is to notice that since 0 is the input to h inverse, it would be the output of h. So you could replace that with 0, solve this equation, and that would be a straightforward way of actually evaluating what h inverse of 0 is. So I replaced 0 as the output into the function h, because 0 is the input into h inverse. Solving that equation would be very quick. You would subtract the 4 on both sides. Since the negative 2 is being multiplied, you would divide by negative 2 on both sides. You would see that the real value of h inverse of 0 turns out to be x equals 2. Simplifying this down, you get 2. So h inverse of 0 can't be 4 when we just shown that it's 2. So choice D is wrong. Unfortunately, 90% of my viewers probably just stopped watching the video because if A through D are wrong, then E must be the one that is true. But for those viewers still watching with anticipation, let me do the last part that says h inverse of 0 is 2. So one way to verify this is to swap roles of the input and the output. If h inverse of 0 is 2, that means h of 2 must be 0, and you simply could substitute x with 2 and see what happens. If I do that, I get negative 2 times 2 would be negative 4, and if you take negative 4 and add 4, you do indeed get 0. So this is a true statement, so the choice is E. If you still want more, the straightforward way to do this problem is to simply say that 0 is the input in h inverse, which means that 0 would be the output of h, so you would replace the output variable of the function, h of x, with 0, and you would solve that equation. If this were not a multiple choice question, this is how you would have to do the problem. So to solve for x, you would simply subtract 4 on both sides, and since the negative 2 is being multiplied, you would divide it over and see that x simplifies down to be the number 2. So if 0 is the output of this function, the input must be 2. In terms of the inverse, you would state it the other way. 0 is the input in h inverse, and the output would be 2. Either way, we've verified this is a true statement.